Hi, I am Miss Lamo, and welcome to the video on how to find the coordinates for a unit circle broken down a little bit. So this video is going to review a couple things. We're going to review special triangles, meaning 30, 60, 90, and 45, 45, 90 triangles. So if that is not review for you, if you don't know, ever heard of those before, I can recommend going back and watching another video on those before you come to this lesson. The other thing we are going to review is basic degrees of the unit circle. And we'll go over that, but it will be kind of quick so you can watch my other videos to kind of understand a little bit more how to get those degrees and also the radians of the unit circle. So let's go ahead and begin with looking at these special right triangles I have over here. And let's say this one is at 30 degrees. It's a right triangle. And this one's at 45 degrees. It's a right triangle. And this one is at 60 degrees. So just, again, you can kind of ignore the circle right now. We're just going to review these 30, 60, 90, 45, 45 degree triangles. So again, you should know if this side is 30 and this side is 90, that this side has to be 60. So they all add up to 180. And same thing over here. If this one's 45 and this one's 90, then you know this one has to be 45. And again, same thing over here, you know this one has to be 30. Now we have learned in the past that there are special relationships to these special right triangles with these given degrees in relation to their side lengths. So we should know that for a 30, 60, 90 triangle, the short side, the side across from 30 degrees, will always be equal to a value. We'll call that value x for now. You know the hypotenuse of that triangle will always be equal to twice the value of the short side. You know the long side of that triangle will always be equal to the value of the short side times rad 3. And again, we can prove this in another video, but for now, the expectation is that you understand this and you have a basic understanding of why, and that this will always be the case in a 30, 60, 90 triangle. Then we go down here for a 45, 45, 90 triangle. We'll call this side length x down here. I know for this triangle, the two side lengths will always be the same because it is an isosceles triangle. These two angles are the same, so I know these two side lengths are going to be the same value. And for this particular right triangle, 45, 45, 90, I know the hypotenuse will always be equal to the side length times rad 2. Then I have down here, I have another 30, 60, 90 triangle. It's the same thing as up here, except down here, I just kind of flip the sides. So now my short length is down here. My long length is going to be equal to that x times rad 3. And my hypotenuse will be 2 times the value of that short side. All right, now I'm going to get into this, and let's say I gave you a 30, 60, 90 triangle, and I told you that the hypotenuse was equal to 1. Could you solve for the other two lengths of this triangle? Your answer is yes, I can. So I know that 2x equals 1, so I need to figure out, okay, well, what is my x value and what is this side length down here? So you could solve this algebraically. Say 2x equals 1. How do I solve for x? Well, divide both sides by 2, and I get x equals 1/2. So I could say, okay, x equals 1/2. So that makes sense. My short side length is 1/2, and my hypotenuse has to be twice that, which is going to be 1. Then down here, what is my long leg? Well, my long leg will always be the short leg times rad 3. So in this case, it's going to be 1/2 times rad 3. It's going to be equal to 1 times rad 3 is rad 3 over 1 times, there's a little invisible one down here, sorry, 2 times invisible 1, 2. So we'll have rad 3 over 2. And just for reference, I'll write this up here, rad 3 over 2, if you were to plug that into your calculator, you would get about 0.87. So for reference, here's about 0.5. This one's a little bit bigger at 0.87, and that one's the biggest at 1.0. All right, let's move on to the 45, 45, 90 triangle. Let's say I told you that this hypotenuse was now 1. Could you solve for the other two sides? You'd say, yes, I can. And I could solve this algebraically. I know that x times rad 2, or my side length times rad 2, is going to be equal to 1. So can I solve for that side length or that x value? I can. Divide both sides by rad 2. I'm left with, let's see, these cancel out. I'm left with x equals 1 over rad 2. For some annoying reason, we can't have a radical in the denominator, so we need to get rid of that. And the best way to do that is always going to be to multiply the denominator by itself. Because rad 2 times rad 2 will just give you rad 4, which is 2. Rad 2 times rad 2 is 2. But in order to keep the fraction the same, I need to multiply. I can only multiply it by 1. So if I multiply the bottom by rad 2, and I have to multiply the top by rad 2, it's just a fancy way of writing 1. And I end up with 1 times rad 2 is rad 2. Over rad 2 times rad 2 is 2. And that is something I can work with. So I know my side length will be rad 2 over 2. And over here, my side length will also be rad 2 over 2. And again, if I wanted to double check that, I know that rad 2 over 2 is my side length. So if I take my side length and multiply it by rad 2, I should get 1. Let's see if I do. Rad 2 over 2 times rad 2 over 1. And I can draw my little invisible 1. So we do rad 2 times rad 2 is 2. 2 times 1 is 2. And that equals 1. So if I multiply my side length by rad 2, I do get 1. So you know that. Erase that. And just for reference as well, I'll write this up here. Rad 2 over 2, if you plug that into the calculator, you get about 0.71. But can just kind of help you kind of estimate if this was 1, this would be about 0.7, and this would be about 0.7. All right, last one we're going to do is our other 30, 60, 90 triangle. Again, let's say I told you that that was equal to 1, the hypotenuse. Well, we already worked that out algebraically up here in the purple. If 2x equals 1, then what is x? Well, this is 1/2. And what is x rad 3? Well, rad 3 over 2. All right, now let's come back over here to our unit circle. Now remember, a unit circle is a circle with a radius of 1. So what is your equation? Well, let's see, in graphic form, my equation for a circle is going to be x minus a squared plus y minus k squared equals r squared. For this particular circle, I'm saying my h is 0 and my k is 0. My center is at 0, 0. And my r is going to be 1 because I have a unit, 1 unit. So what is the equation for this circle? Well, x minus 0 squared plus y minus 0 squared equals 1 squared, which is 1. This is just a circle for that. If I were to extend the grid out here, get 2 and then 3 and so on. Same thing over here. I'd get, here's -1, there's -2, and it can go up and up. It's like if we took a regular x and y graph and just zoomed in to have only one radius, this is what it would look like. So on that note, let's go ahead and fill in our coordinates for these little easy spots. Here, and here, and here, and here. Well, again, if this is 0, 0, and I went over the right one, and I moved no up and down at all, my coordinate will be 1, 0. I'm going over here, I'm at 0, 0, I go left and right none, but I move up 1. I will have 0, 1. All right, again, I'm starting at the origin. I'm going to the left 1. My coordinate will be -1, 0. And now again at the origin, going down 1. Erase this. And my coordinate is going to be 0, -1. All right, now the rest of this video is going to be spent figuring out the other 12 coordinates that we have. So how do we do that? Well, let's see, what do these spots represent? We've already gone over the unit circle. You know that we do the unit circle in 2 different ways. Sometimes we look at it in degrees, and sometimes we look at it in radians. So I'm going to look at it in terms of degrees because I think that will help you understand the coordinates a little bit better. In the other video, we can talk about how degrees and radians are related. But let's say we took this angle right here and we made this 30 degrees, meaning if we took a protractor and we stuck it right here on this line on the x-axis and we measured 30 degrees, that's where it would be. That would be the angle. And we would take that angle all the way to our circle. And we would say, okay, that is going to be at 30 degrees. I'm going to change the color actually. Let's do degrees and blue. So that becomes 30 degrees. If we were to go up a little bit more, this is 45 degrees. This is going to be 60 degrees, 90 degrees. If we were to go all the way over here, we would have 180 degrees. And then if we were to, again, go up, not this one, if we were to go up 30 degrees, we would take 180 degrees, but subtract that full 30 degrees, we'd have 150. If we were to take 180 and subtract 45 degrees, we would end up with 135. And if we were to take 180 and go up 60 degrees, subtract going backwards 60 degrees, we would be at 1. Another way to look at this is if, again, if I started here and I took my protractor and I went 150 degrees, my angle would be here. So the angle between this line and this line is 150 degrees. The angle between this line and this line is 180 degrees. It's a straight line. If I were to keep going from there, so that 180 degrees, and then go 30 degrees more, I'd be at 30 plus 180, I'd be at 210. Okay, and let's say I was here at 180 and I went 45 degrees. 180 plus 45 is going to be 225. Now let's say I was at 180 and I went 60 degrees, I would be at 240. Now if I was at 180 and I went complete 90 more degrees, I would be at 270. All right, now I'm at 270 and I'm going to add 30 degrees to that, maybe 300. If I were to add 45 to 270, I would be at 315. And if I were to add 60 to 370, I would be at 330. And if I were to add a full 9 degrees to 270, I would have made a complete circle, 360 degrees. This is also 0 degrees because you start here and you end there. All right, so now we have our degrees. Let's try to figure out what our coordinates are. So we're going to write coordinates in black, like we did right here, 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 and here. So how do we figure out what is coordinates at 30 degrees? Well, look. If we were to take this little triangle we made, take that and plug it in, hopefully it fits right there. Look what we formed. We formed a 30, 60, 90 triangle. It's got a little imaginary line right down there. So we know if we have this right here is 30 degrees, we know that by drawing a line straight down, we created a 90-degree angle. So that must be 60 degrees. What else do we know about this? Well, we know that the unit circle, again, means our radius is 1, which again, the definition of a radius is any point from the origin of the circle to any point on the circle is the radius. So anytime I start the origin and I draw a line out to the point, that's going to be equal to the radius, which is 1. So if I have a 30, 60, 90 triangle and my radius is 1, what are my other side lengths? Well, I have, looks like that 2. Didn't quite make it start again. Well, I need to figure out what my coordinate is right here. And what's a coordinate? A coordinate is x, y. Just like here, we went over 1 is our x, and we went up and down 0 was our y. I need to figure out how far over did I go, and then how far up did I go. Remember, this is 1, and this is 1. So how far to the right did I go? Well, I went less than 1. What is that number? Well, look at that. This side length of this triangle is radius over 2, or we said about 0.87, which looks about right. That would be about 0.87 if that was 1. So I went to the right to get to this point. I went to the right, radius over 2. And then I went up. How far did I go up? I went up 1/2, which again makes sense. Starting with right here, about halfway between 0 and 1, because I went up 1/2. So what is my coordinate here? 30 degrees. Well, it's going to be rad 3 over 2, comma 1/2. Now look at this. If I were to come over here, I said between 180 and 150 is also 30 degrees. If I were to draw a little, make my little imaginary right triangle that I have here, I have another 30, 60, 90 triangle. I have a radius of 1. I know my side length, my short side length, I should say, the one across from 30 is going to be 1/2. And I know my long side length, the one across from 60, the long one, is going to be roughly. All right, can I figure out this coordinate? Well, this time I went to the left, roughly over 2, or negative 0.87. This is -1, this is about negative 0.87. We like to write it in the exact form. I'm going to keep it as a fraction. Negative √3 over 2, comma, and then I went up 1/2, just like I went over here. The y coordinate. All right, and like you might see a pattern. Then from 180 to 210, it's another 30 degrees. I can make another right triangle. All right, here's my other one. Here's my radius of 1. Oops. For that to be perfect. Right here, because it should go all the way to this. So another 30, 60, 90 with my radius of 1. And my short side is going to be 1/2. The side across from 30 degrees is 1/2. And my long side, the one across from 60 degrees, is going to be √3 over 2. So what is my coordinate here? Well, this time I went to the left, √3 over 2. So my x coordinate is negative √3 over 2. And I went down 1/2. So I have negative 1/2. Also, maybe you can figure out what the coordinate is right here. If you want to pause the video so you can figure that out, you can. Otherwise, we'll keep going. So you should see that you'll see another 30, 90 triangle. Throw one right here. So my side across my little one, 30 degrees, is going to be 1/2. And my side length across from 60 degrees is going to be right here, right here over 2. The same length as the one right above it. So where's my coordinate here? Well, this time I went to the right, rad 3 over 2, positive. And I went down 1, negative 1. All right, if you want to pause the video right here and see if you can do 45-degree angles, you're welcome to try that. All right, let's keep going. So now I'm going to look at my next angle at the 45-degree line right here. My degree looks fine. All right, so, oops. All right, so I have this 45, 45, 90 triangle. I move that to be about here. Not perfect, but I found it. All right, let's look and see, okay, what are my coordinates going to be here at 45 degrees? Well, again, I have that triangle I made. I drew a line down, so I created that right angle. I knew this one was 45 degrees, because that's what I'm measuring, 45 degrees. So this one has to be 45 as well, 45, 45, 90. I know my radius is 1, because that's the radius of the circle, so my hypotenuse is 1. So I know in a 45, 45, 90 triangle with a hypotenuse of 1, the side length will be rad 2 over 2 and rad 2 over 2. So how far to the right did I go? Well, I went rad 2 over 2. And how far up did you go? Well, I went up rad 2 over 2. And again, for reference, we said rad 2 over 2 is about 0.71. So it makes sense. It's a little bit less than this one, 0.87. It's not quite half. Again, here's half, so it's going to be a little bit more than half. Here was the halfway mark on the y. Here's the 0.71. All right, then let's go over here. We go on this quadrant 2, so this is quadrant 1, so quadrant 2. And we said this right here is a 45-degree angle between this line and right here, between 180 and 135 is 45. Then again, if I were to draw, I have 45, 45, 90 with the hypotenuse of 1. I know my side lengths are rad 2 over 2 and rad 2 over 2. So what are my coordinates? Well, I went to the left, rad 2 over 2, so it's negative rad 2 over 2. And I went up rad 2 over 3, so positive. Again, if you'd like to pause the video at this point, you can see if you can do 225 and 350 on your own. I'll keep going. So right here, I'm going to have another 45-degree angle between 180 and 225. I would just draw that triangle. I would end up with 45, 45, 90. The hypotenuse again is 1. My side lengths are still going to be rad 2 over 2. And so is this one, just like the triangle above it, that side length stays the same, rad 2 over 2. My coordinates, this time I went to the left, rad 2 over 2, so negative rad 2 over 2, and I went down, again, about 0.71, so negative rad. And then over here, maybe you'll see by now that my coordinates are still going to be rad 2 over 2, comma rad 2 over 2. I just need to figure out which one's negative and which one's positive. Well, for this coordinate right here, I went to the right, rad 2 over 2. Same thing I'm going to do for this coordinate. I went to the right, rad 2 over 2. But this time I went down, rad 2 over 2. Same thing I did over here. I went down, negative 0.71. So that the y value is negative in the fourth quadrant. All right, here we go. Last one. Do that 60 degrees. We take this one, plug it in about there. What are our coordinates going to be? Let's see. So I have a 60 degrees, 30, and 90. So I still have that 30, 60, 90 triangle, but now my coordinates is just flipped. because now my short side is going to be the x value and my long side is going to be the y value. So how far did I go over with my short side? What was that? X and then x value. But the x value is going to be 1/2. Makes sense because this is 1/2, about 0.5. We said this is about 0.7. This is about 0.87, and here's 1. So that makes sense going that way. And then going up, we said if this side was 1/2, that side was rad 3 over 2. Rad 3 over 2. Which again, we said is about 0.87. So if we look at our y value here, right here, we were at 1/2 for the y value. Here we were at 0.71 for the y value. And here we're at 0.87, and there's 1. All right, can you figure out this coordinate? Again, we created a 60-degree angle right here. Try to draw a triangle. This would be 30. My radius is 1. My short side is going to be 1/2. So I know I went to the left 1/2. And my long side is going to be rad 3 over 2, and I went up. All right, here's my 60-degree angle here. 180 plus 60 is going to give me 240. So if I create that 60-degree angle, I create this little 30, 60, 90 triangle here. My short side is going to be 1/2, same as this one. So just like this coordinate, I went to the left 1/2. And my long side is going to be rad 3 over 2. I went down. Negative rad 3 over 2. All right, and then here's our last one. I have my right here. If I were to create a 90-degree, or sorry, not 90-degree angle right here between 360 and 300, it's going to be 60-degree angle. Here's my right angle. Here's my 30 degrees, 30, 60, 90. Again, my short side over here is going to be 1/2. My short side is 1/2. Just like over here, I went to the right 1/2. And again, I went down rad 3 over 2. Wow, that's a lot of work. But we got those key coordinates. If you can remember your coordinates right here in quadrant 1, you can really fill out this whole unit circle as long as you remember your signs in your quadrant. So again, here's our quadrants on a graph. We have quadrant 1, 2, 3, and 4. This is the origin. And we know in this quadrant, our coordinates will always be positive, positive, because we go to the right, so our x is positive. And then we go up, so our y is also positive. Pause this video and see if you can fill in the rest of this chart. All right, let's see. Did you get over here to the quadrant 2? Your x value will always be negative because you're always going to the left. And your y value will always be positive if you go up. Quadrant 3, you should have gotten negative, negative because you go to the left and then down. In quadrant 4, you should get positive to the right, and then y value is going to be go down. So again, if you can remember your length to that 30, 60, 90 triangle, and you can then point out this one and this one and this one, and then just remember what signs to give them, you can fill out all of these coordinates, and you can draw the coordinates to any angle on the unit